Attendees are in listen-only mode.
Good morning, everyone, and thank you for attending today's webcast, What's New in Autodesk Inventor HSM 2016. Our presenter today is Matthew Nichols. He's a solutions engineer with Hagerman and Company. We're also joined on the line by Mark Lautenbach, and he's going to help field questions. Mark is also a solutions engineer with Hagerman and Company. Before we get started, I want to let you know that you're in listening only mode. If you have questions during the presentation, just type them into the question panel on the right-hand side of your screen, and they'll be addressed throughout by Mark and at the end by Matthew. As you exit the webcast today, you'll be prompted to fill out a survey, and we ask that you take a few moments to do that. Additionally, all attendees will receive a certificate for attending today's presentation. And with that, I'll hand things over to Matthew.
Thank you, Ashley. Thank you, everybody, for joining us today for the What's New in Inventor HSM 2016. So today we're going to cover some of the new features in HSM, and as well as one that will be a big role player in that's new in Inventor with the Inic Add. So let's go ahead and look at some of the major new additions to HSM 2016. So with the release of HSM 2016, we had a couple of new stock options added to our list, as well as turning is now available for the HSM and HSM Pro, and we also have the addition of the Inic Add feature within Inventor. So first, what I want to do is I'm going to kind of look at what's involved in these new features, and then we'll dive into the actual program and take an actual deeper look into them. So first, with the new stock options, we've added fixed size 2, where you can define an actual OD and ID along with the length to define your tube, or a relative size tube, which with that there's 4 fields involved. You can do the radial offset, which defines your OD, front and back side offsets, and then a round up to nearest, which controls your ID. And then with turning, all the toolpaths that are involved with our turning option are profile, where within profile you can define whether you're doing outside profiling or inside boring, grooving, outside or inside spacing operations, threading, parting, single grooves, chamfer option, and stock transfer for multiple spindles. Another feature that's included that's kind of built into the actual job setup is what we call a spun profile. So what this allows you to do if you have complex features on a part that you're actually turning, it goes from not seeing all the features as one whole half part, to where it's actually seeing even cuts and grooves and defining it as a full feature. So we'll take a closer look at that as well here in a minute. And then again with the Inic Add feature, with this we're able to create a direct link with an external part that may have been created in a different CAD software, such as Siemens NX, SolidWorks, ProE, or CATIA. And then whenever a change is done to those files, if you've got that direct link created or made, if that change is done, you'll get an automatic update notification within your Inventor saying that that part has been changed. So with that, let's go ahead and take a look at these features inside of Inventor. So what I kind of want to start off with is this whole V-belt pulley, just to show some of the basic features of the turning options. So in the setup, I can go ahead and define my model. And now the new thing here in our setup is we have this option for turning our mill turn. So once I activate turning, I now have the option to define the spindle that I want to use within my machine, define the work coordinate system. I can even define how I want my origin point to be defined, whether I want it from stock or model. Here, underneath the model is where I can define whether I'm using a spun profile, and we'll look at this at a part in a few minutes. And then here on my stock tab, I have, now I can see fixed size and relative size too. Now if I go into these, you can see that I have my option of my diameter, my inner diameter, and then the overall length. And then that positioning of that length can also be defined by this model position, where I can define how I want my offset of that stock solid to be pertaining to my actual part. And then I can actually give it an offset value of how I want it to be off that face. So that's fixed size. Relative size too, here again, if I do this, I can go in and I can define a radial offset, a front and back offset, and then I can tell it how I want it to round up, which will also help control my actual OD of the part as well. And then once you do that, you can also see definition of width of your actual dimensions of your tube in this dimensions panel. But for this one, what I'm going to do is I've actually got a solid stock that I've created inside of my model. So I'm going to go ahead and select that for defining, and then we're ready to put some toolpaths on this part. So first what I want to do is a facing operation. And in here I've already got my tools defined for what I want to use. I'm going to go ahead and pick my initial tool. Now you'll notice here, even before actually creating this toolpath, I've already got a preview of what the toolpath is going to look like. So with that, I'm going to go ahead and click OK. Now you'll notice one of the things that's really awesome about the turning in HSM is that as I do these toolpaths, you'll see the stock outline conform to what the part is actually going to look like. So you'll see now I've got this facing operation done. I'm going to go into my profiling. Using the same tool, I'm going to define a confinement area for the tool to stay within, because I'm going to have this part mounted in a chuck that's going to be on this back part initially to start. So once I set that confinement, and then give a little changes to my heights, I can go ahead and hit OK. Then I've got a profile. Now, one thing in here is in this path, you can see that my profile is grooving down into those little, in those V notches for where the belt would be going. So let's say I didn't want to do that. Let's say I wanted to just go straight across there. I can go back to my toolpath, and underneath the model or the mode and direction, I can turn off allow grooving. Now that allows it to just calculate for a straight across profile. So with that, now I can go into a grooving operation. Select my grooving tool. Again here, set confinement. Turn on rest machining. And hit OK. Now let's say I want to go in here and I want to do my profiling on the inside of this part. I'll go into my profile again. I've got my boring tool. And now for this, what I want to do is I want to change my mode to inside profiling. And then again, I'm going to set a confinement from the front face to the back of this little chamfer and turn on rest machining. So here you can see, now I've got the front of this face profiled out to the back of this back to this face on the opposite side, which we'll come back in a minute and finish that out as well. So now what I can do is I'm going to go ahead and drill and tap these holes. And for that, I'm just going to use my standard drill toolpath. And now notice I've got my select same diameter selected, so it went ahead and found all the same diameters. And then again, if I do that for the tap, finds them all for me again. Now, what I can do is to go about making the second setup, I can either go start the setup process again for defining stock, model, and all that stuff. But basically what I want to do is I want to use the same setup, and then I'm going to be using the same toolpaths minus my drilling operations, my drill and tap. So what I want to do is I want to right click on this setup, and I want to say duplicate. Now I know I'm going to get rid of those drilling operations, and then what I need to do in here is come in and switch my Z-axis so that now my Z will be on the front of this face, showing that my chuck will be on the back side. And then what I want to do is I want to turn on continue machining from previous setup. So now once I do that, you can see here on the facing operation that my facing operation is now flipping to the back side. So all I need to do is hit generate. And now you can see that from checking that continuous machining from previous setup, it's got all the stock removed still from the last setup. And now all I have to do is remove what I need to on this side. So it's just going to be going into these different setups or these different toolpaths and redefining confinements. So it's pretty quick and easy on being able to reuse setups and toolpaths that you have previously used to do the opposite side of a part as well. So that's kind of a basic look at how the operations work and some of the functionality of being able to duplicate setups and all that. Now, with that, let's go ahead and take a look at our spun profile and how this will play a role in our parts. So I'm just going to go ahead and start with creating a generic setup with my model. Again, going to turning or mill turn. Okay, so I'm going to go ahead and use that. Now once I do that, I'm going to go ahead and throw a facing operation on here. And then I want to throw a profile operation on here as well. So now you'll see that the outline isn't quite what I want it to be, and the toolpath is definitely not going where I want it to go. So to fix that, let's go in our setup and then activate our spun profile. Hit OK. And then what I want to do is just regenerate those toolpaths. So now you can see that having activated the spun profile, I've got a much clearer section of the part that will give us a really good definition to it. So if I go ahead and do a simulate on this, you can see now that with that change, the toolpaths are giving us a proper part rather than one that's completely removed, as it would have been with the previous setup. So now I want to go ahead and look at some of the Inic Add functionality. So what I've got here is a part that also has, that's linked to a SolidWorks part that I've got, and then I've got a chuck here kind of representing the chuck for my lathe. So now what I would do is, let's say I go about creating the setup for this part. Okay. I'm going to go ahead and leave it as 6-cylinder, and I'm just going to make it 2.625 and then 5.75. That way we can do an offset from the front of 60 thousandths. And then what I can do at the end is I can actually create a parting toolpath to part this part off. So go ahead and hit OK on that. And then we're just going to put spacing on here. Profile. I'm going to go ahead and define a confinement. And then I want to give it a back offset so that I go past the part a little bit, or past the end of it. Okay. And then lastly, what I'm going to do for this is do grooving operation. And then for here, I know that that previous profile kind of came up to here, so I'm going to pick on this end and pick here. Then I'm going to give it a back offset of 0.12. Okay, and then the last thing I'll do is I'll do a part using the same tool. So now I've got this completely programmed. Let's say one of the designers goes in and he changes the part, but it's not an Inventor, it's a SolidWorks part. So let's say in here, if I go into this sketch, I'm going to change this little length of this section. I'm going to change the height of this. And they changed that on me. Okay, now what I want you to see here is, as I hit save, my Inventor literally lit up right after it saved. So now if I go into here, I can go ahead and hit an update. Generate it, and now all my toolpaths are updated to what the new profile would look like. All right. Now let's take a quick look at threading. I know this is a big thing for a lot of companies. So let's take this. This is going to be a 3/4 10 thread on this face. So what I've got on the stock is, this end would be in the chuck. So what I need to do is obviously do a facing operation. And then I'm going to do a profiling with my confinement. Okay. Then for the threading, I've already got my tool defined. and then I'm defining outside threads. Now in here, all I have to do is I'm actually picking a face in which threads are going to be on, and then you can already see that I'm getting a preview of what the toolpath will look like. And then once I go to my Passes tab, I can define further whether I'm doing right or left-hand threads. Here I define the actual depth in which my threads are going to go, and then I define the pitch, which I know for 3/4 inch thread is 0.1. And I can also define how many step downs I want the tool to take to create that. So you can see here I've got 1, 2, 3, 4, 5 step downs. So that's defined by this value right here. If you want, say you're doing something that has a longer thread length on it, or more of a surface that's doing threads, I can select an option here for spring pass, which will do 2 more finishing passes to compensate for any deflection that may have happened in the part during the initial threading. So if I go ahead and click OK on that, I now have a threading tool pass, but you can't really see it in here. So the way I love to do this is if I go in here to my model, I'll literally turn off all the solids. I'll go back into my cam tab, and then I do a simulate just like this. And this really helps to get a better visual of what your finished product will actually be on a part. So I've got my stock turned on. I'm actually going to turn off Toolpath, and I'm going to go ahead and play this. Now again, on these, I get all my statistics and info for the actual tool passes. Now, before it goes into this, I'm going to go ahead and turn it down so you can see this, because I love watching this part. So it's kind of nice to be able to simulate this without any of the solids on, so you can get a real representation of what the threads will actually look like on the part. Because if you had solids turned on, you wouldn't actually be able to see it in this way. So now let's do so some other features that are new to the 2016 release. There's been some updated post-processors. Haas mill turns, Pocket NC are some of them. Another one is CamPlete, which if you don't know, CamPlete is a machine simulation software. So there's the ability to do a CamPlete APT file that will then translate into their software. Also, there's lots of different improved toolpaths, but the most or the largest one would be what they're calling adaptive clearing 2.0, which is a better calculation of the actual passes on the adaptive clearing itself. Are there any questions?
Doesn't look like it at this time.
Nope. Okay. So the speeds and feeds, right now they currently are driven just by how you identify them inside the tool. So if I go in here, I define the speeds and feeds inside the tool. I can define whether I want by spindle speed. I can check for constant surface speed if that's how you define it. For my feeds, again, cutting feed rate, or if I do feed per revolution, I can do it that way as well. Now, with that, once you define it in the tool itself, if you go inside of a toolpath, I can also define it in here. So by changing it in here, it basically creates an instance inside of the library. So let's just say, for example, 800 RPM. And then if I go into here, turn on spindle speed. Oh, spindle speed. Yeah, that's okay. But so it would change in here, and then that would be able to be used later on. But what we typically suggest doing is creating different libraries of the tools that you have that would then have the feed and speeds that would be for a certain material. And the easiest way to do that would be once you create one library, you can export those tools out to a TSV file or a tab delimited file, and then make all the changes and make copies of that tab delimited file for the different libraries that you would use, and then import those into your new libraries. And that's the quickest and easiest way to do mass changes like that. So turning is available at the HSM level, the mid-level. So there's the three, there's Express, HSM, and HSM Pro. So turning is available with the HSM level.
Well, Matt, it seems like there haven't been any more questions coming in. We can hold on the line for a few more moments. But otherwise, if you have additional questions that you think of later, you can simply reply to the confirmation or reminder email you received, and we can get those to Matt, and he can help you out with those at a later date. Once again, as you leave the webinar, you'll be asked to fill out a survey, and we do ask that you take a few moments to fill that out. And otherwise, we'll hang on the line here for a few more minutes in case some more questions trickle in.